In this video, I'm going to wrap up the first half of the powers and factors unit of Math 10. We're going to dive a little bit more in depth into roots, which is what I covered in the last video. And we're going to see something called mixed and entire radicals. And so that might seem like a new and intimidating concept. You've probably never heard of a radical before, but you actually have, because really all of a radical is it's something that involves a root. So it's not really anything super new or different. So like the square root of 5 is a radical. But we can do a little bit more with them when we think of them as radicals instead of just roots. So there's a couple of different kinds of radicals, which you can probably guess from the title. One of them is called an entire radical. And so it's kind of in the name, an entire radical. You'll see in a sec, is a radical that doesn't have a coefficient. And if you've forgotten what a coefficient is, it's just the number out front of a thing, the number attached to something. So like in a polynomial, if you have 2x, 2 is a coefficient. So an entire radical is a radical that doesn't have something like that because the entire thing is inside the root. So some examples of entire radicals might be something like the square root of 45. Or the cube root of 56. Or we can even throw some variables in there and have the square root of 25x cubed. Right? These are all entire radicals. A mixed radical, you might be able to guess just as sort of a differentiator, is going to be a radical that does have a coefficient. And we'll see kind of how that affects things as we go through this lesson. And so that might look something like, say, 3 root 5. Or maybe 2 cube root 7. Or 5x root x. And so it's possible to move in between entire radicals and mixed radicals depending on what you're wanting to do with them. And in fact, the ones that I've listed here are actually the same ones. So root 45 and 3 root 5, those are the same. These are the same. These are the same. So you can kind of represent them differently depending on whether you want to, say, add and subtract, multiply and divide, solve equations, and stuff like that. We're not going to get too in-depth with these this year. Pre-Calc 11 spends a lot more time focusing on radicals, so this lesson is sort of just a gentle introduction so that when you see them next year, you'll hopefully be a little bit more familiar with them. So first up, how do I go from an entire radical to a mixed one? So let's say I wanted to write the square root of 40 as a mixed radical. Here's the nice thing. You already have essentially all the skills you need to do this because everything that we did in the last video involving roots is going to be applicable here. So we're going to start, just like we did then, with prime factorization. So the square root of 40, when we do our prime factorization, that's just going to break down into 3 2s and a 5. Just like we did for square roots, we're going to make some pairs. Or groups, depending on what your index is. And we're going to take out factors just like we did then. So far, this should feel entirely familiar because it's the same thing. But you'll see very quickly that there is a small but crucial difference. So if, like we are here, let's say we're doing the square root of 40. Again, that's 3 2s and a 5. So if we make pairs, we can make a pair of 2s, but you probably see, hopefully, that we have some stuff that doesn't fit into a pair. So we've got a 2 and we've got a 5, and neither of those has something to pair with. So these two things, these unpaired factors, are going to stay put. They're left inside the root. That pair of 2s is going to come out in the same way that it did before. So we are going to have 1 2 on the outside. But then on the inside, we're still going to have a 2 and a 5. And then to finish this off, we just do any simplifying that we can, any multiplying or whatever. So the square root of 40 ends up being 2 root, and then 2 times 5 inside the root gets us 10. A key thing to remember here is that when you have a number next to anything, right, a coefficient, that just means multiplication. So 2 root 10 is 2 times the square root of 10. And you can test this for yourself. The square root of 40, if you run it through a calculator, is about 6.32. And 2 times the square root of 10 is also about 6.32. They are the same. All right, let's try another one. So let's say I asked you to write something as a mixed radical, and more specifically in simplest form. The reason I say in simplest form, and I'm even going to underline it, is because there might be more than one thing that you can pull out of a root. So maybe you can pull out a 2 and a 5 or something like that. And so you want to try to pull out everything possible. If I asked you to deal with, say, square root of 200, that could be written as 10 root 2, which would be the simplest form. But it could also be written as, say, 2 root 50, or 5 root 8. And those are all mixed radicals. But the one at the top there, that 10 root 2, that is the simplest form. It's kind of like with fractions. If I ask you to simplify, say, 8 over 12, you could divide the top and the bottom by 2 and get 4 over 6, and that is simplified, but it's not the simplest version. So let's see if we can simplify, say, the square root of 112. I'm going to skip through doing prime factorizations for this video. You've hopefully seen it enough at this point that you understand how to do it. So if you're still a little bit stuck on the finding the prime factorizations, go back to the appropriate video and get a little bit more help there. So 112, when we break it down, turns into 4 2s and a 7. So if we're going to make some pairs here, we can make a pair of 2s, and we can make another pair of 2s. And so each of those pairs is going to contribute 1 2 on the outside of the root. And then anything that didn't get paired, which in this case is just the 7, is going to stay on the inside. And then to finish this off, we just multiply the stuff that we pulled out. So we've got 2 times 2, which is 4. And this is 4 root 7. All right, so try this next one for yourself. So the root of 2160. So try to simplify this, pull as much stuff out as you can as possible. So when you do your prime factorization, 2160, which is a much bigger number than some of the other ones we've seen, is going to break down into 4 2s, 3 3s, and a 5. We'll make some pairs. We've got a pair of 2s, another pair of 2s, and a pair of 3s. So each of those pairs gives us something on the outside. So we've got 2 2s and 1 3, so 1 for each group. And then inside, we've still got a 3 and a 5. And so if you multiply that all, you end up with 12 on the outside, 15 on the inside. One thing I do want to emphasize, when we say simplify, there is a not super common but still relatively regularly seen mistake of thinking, oh, okay, well, if I have 12 root 15, this is like a fraction, so I'm going to divide both of those numbers by 3 and turn this into 4 root 5. You're welcome to test this on your calculator, but you can very easily see that these are not the same. Please don't do this. These numbers are not equivalent, and that is very wrong. It's the same thing as basically saying that, I don't know, 5 times 10 is the same thing as 1 times 2 if you divide them both by 5. So try not to do that. That works for fractions and division. It does not work for multiplication. And it definitely doesn't work with radicals. Okay. If we tried the cube root of 200, so 200, if we break it down, is 3 2s and 2 5s. And so just like when we were doing roots, having a cube root or a fourth root or whatever just means that you change how many things have to go into your group. So this means we're going to have a group of 3 2s instead of 2 2s. So we're going to make not a pair, but a group of 3. which means we'll have 1 2 on the outside. And then those two 5s are still on the inside, so we've still got a 25 in there. So that pair of 5s isn't actually a pair. We can't make a group out of them. Okay, a few more quick ones, and then we'll see about going the other direction. So if we wanted to do the root 42, if we break down 42, that's a 2 and a 3 and a 7. And so if you look at that, you can hopefully pretty quickly see that, well, nothing here can go into a root, or into a pair rather. So root 42 is really just root 42. We can't write this as a mixed radical. You have to have something that can be paired. So not everything can be written as a mixed radical. And on the opposite end of the spectrum, if we wanted to do root 36, so 36 breaks down into 2 2s and 2 3s. And so everything goes into a pair here, because of course 36 is a perfect square. So sometimes everything fits into a pair, sometimes nothing fits into a pair. And then one more. If we had something like, say, 2 root 18. So if you look at this, this is a mixed radical already. But I want to try to get it into the simplest possible mixed radical. So we can still take some more stuff out of that root 18. So if we break this down, the 18 is going to become 2 times 3 times 3. And we can make a pair of 3s. So let's ignore that 2 for a second, the one that we already had on the outside. So the root is just going to be now 3 root 2, right? But the thing to remember, 2 root whatever, this is multiplication. We talked about this earlier. So in here, this is a multiplication. So 2 times the root means we're doing 2 times that mixed radical that we just made. So that's 2 times 3 root 2. So we're just going to have to multiply. But you're only going to multiply the stuff on the outside. So you're going to multiply the 2 and the 3, but it's not foiling or distributing. You're not going to multiply that 2 outside of the root with the 2 inside of the root. You're just multiplying coefficients. So 2 times 3 root 2 becomes 6 root 2. What you've basically done is something like 2 times 5x. Right? 2 times 5x is 10x. It's not 10 2x or anything like that. So you're not distributing that 2 through when you're multiplying. You're just multiplying the coefficients together. So now we want to go the other direction and do mixed radicals to entire radicals. Thankfully, this is a much quicker and less complicated process, though we don't have quite as much background information about it. So an important thing to know before we do this, kind of the reverse of something I talked about earlier, is that if you multiply 2 roots with the same index, so 2 square roots or 2 cube roots or whatever, that's the same thing as having 1 root that multiplies the 2 radicands together. So a square root and a square root just becomes kind of 1 root. So for example, if we did the square root of 6 times the square root of 10, that's just the square root of 60, right? Or 6 times 10, to break it down a little bit. And that's going to be really important in helping us convert these mixed radicals to entire radicals. So let's say I wanted to convert 3 root 5 to an entire radical. So I can't just do 3 times 5 because the 3 is not in a root. So my actual first goal is to take that 3 and turn it into a root. So we're going to put the coefficient into a root. And you can do that different ways, but the most straightforward way to think about it is by using exponents. So 3, remember, is the square root of 9, right? So we know that 3 is the square root of 9. But how do we get to the 9? So if we kind of chop that out and come about it from a more roundabout way, 9 is just 3 times 3. So 3 is the square root of 3 times 3. So we're undoing the stuff we were doing up above here, right? Where we took, say, oh, hey, look, a 3. So 2 3s inside of root became 1 3 on the outside. Now we're going the other way. 1 3 on the outside of root is going to become a pair of 3s on the inside. And we can think of that, if we want, as 3 squared instead. So 3 root 5 becomes root 3 times 3, and then root 5. So, right, the 3 gets put into a root, which is root 3 squared if you want. I'll throw it in there as a step, although you don't have to. Or root 9. So we take the thing on the outside, we turn it into the appropriate square root. From there, well, now we've got 2 roots, so we can just multiply them together. So the square root of 9 times the square root of 5 is the square root of 9 times 5, which is just the square root of 45. And if you did the conversion the other direction, you'd see kind of the same thing, just backwards. So the square root of 45 breaks down into 2 3s and a 5, and we'd get that pair, which would turn back into 3 root 5. So you can kind of see the whole thing going in both directions. And there's not really much more to this. So if we converted, say, 4 root 10, so that 4, if we put it into a root, is going to become 2 4s. And then we've got root 10. So, and you can skip that step, by the way. You can go straight to turning the 2 4s into 4 squared or turning it into 16. So 4 times 4 is 4 squared, or 16. So we got 16 times root 10, and 16 times 10 gets us root 160. So it's really this first crucial step of knowing to turn the thing on the outside into 2 things on the inside, or maybe not always 2 things. So if we did 5 times the cube root of 28, so that 5, when you turn it into a root, is going to become 3 5s. So it's going to be 5 cubed. Still times root 28, though, or cube root 28. 5 cubed, if you go through and calculate that, is 125. So we're doing the cube root of 125 times the cube root of 28. And so you might have to go and multiply that either on a calculator or by hand. When you do multiply those, you find out that 125 times 28 is 3,500. Okay, so I'm going to give you a couple to try on your own. So I'd like you to try to convert 12 root 16 and to the 4th root of 15. So turn those both into mixed radicals, and then come back once you're done to see how you did. All right, so for the first one, when you put that 12 on the inside, that's going to become 12 squared, and then times 16. So 12 squared is going to be root 144. The 16 is just 16. And so when you multiply those, you get 2,304. For the one on the right, that 2 is now going to be inside of a 4th root. And by the way I've written it here is a little bit, not necessarily ambiguous, but could be confusing. Be careful when you have an index that it doesn't look like an exponent. So some people might think this is 2 to the power of 4. So it might have been better for me to rewrite it with maybe the 2 slightly farther away so that people can tell really clearly that that 4 was an index. So we've got 4, or the 4th root rather, of 2 to the power of 4, and the 4th root of 15. 2 to the power of 4 is just 16. So what we end up with here is 16 times 15, which is 240. All right, talking about negatives a little bit here. So if we have negative 5 root 2 versus negative 5 cube root of 2, and I want to write these as mixed radicals. So for the one on the left there, we can't actually move that negative inside of the root. So you can't do a square root of a negative, right? Which means we can't have negatives existing there. So when you do this, the negative actually ends up having to stay outside of the root. Because otherwise, it would either disappear or it would break something, neither of which is good. We don't want to get rid of it because we do want the value of this thing to stay negative, right? This thing does have a negative value. And so we can't sort of square it away, but we also can't move it in. But otherwise, this process doesn't really change, right? So we've got 5 squared, we got 2. When you multiply that all out, you're going to end up with 50. We can do it for cube roots, though, right? So you can have a negative inside of a cube root. We talked about that in the last video. So you're more than welcome to move a negative inside of a cube root. You could also leave it on the outside. It wouldn't really matter. But it's okay to move it inside. So if we multiply out negative 5 cubed, that is negative 125. And then multiply that by 2, we get negative 250. So you got to pay attention to what your index is, right? An even index, the negative has to stay out. An odd index, it can go in or out. It doesn't really matter. Okay, one last thing just to kind of wrap this all up. Let's say you were asked to multiply a couple of things and then write them as a mixed radical, a mixed radical in simplest form. Or as entire radical, either way. So once you get into the point where you're multiplying different roots together, this gets a little bit more complicated. And this is something you'll do plenty of in Pre-Calc 12, so or Pre-Calc 11 rather. So I'm not going to go too into it now, but just wanted to give you sort of a preview. So if you were doing 4 root 15 times 2 root 6, so now we're multiplying 2 roots, and both of those roots have coefficients. You could turn these both into entire radicals first and then sort of go through the process. But a faster way to go about it is to say, oh, okay, well, order doesn't really matter in multiplication, right? So if I'm doing 4 root 15, keeping in mind that that is just 4 times root 15, and 2 root 6 is just 2 times root 6, and I'm multiplying those, I'm really just doing a whole bunch of multiplication here. So these coefficients, which are on the outside, and these radicands, which are on the inside, I can just rearrange these things. And so this just becomes 4 times 2, and root 15 times root 6, which turns into 8 root 90. In the same way that if you were doing, say, 4x times 3x, you'd multiply the coefficients together and you'd get 12, and you'd multiply x times x and you'd get x squared. So you multiply the coefficients, you multiply the variables, or in this case, you multiply the coefficients and you multiply the radicands. At this point, we were asked to write this as a mixed radical in simplest form, so we do have to break that 90 down. 90 is going to break down into 9 and 10, which is going to be a 2, a couple of 3s, and a 5. Got a pair of 3s, so you're going to pull that out, which is going to give you 8 times 3 root 10. And then remember, we're just going to multiply the 8 and the 3, and so we're going to get 24 root 10. And so there you have it. Those are mixed and entire radicals, and that does finish up sort of the first half of this unit, which was all about prime factorization, factors, and using them to do different things, you know, the greatest common factor, lowest common multiple, and this root stuff. Once you're ready, go ahead and move on to the second half of the chapter, which is going to focus all about exponents, so different things with powers, exponent rules, and some new kinds of exponent rules that you haven't seen previously. So once you're ready, go take a look at that.